Hello again. This is like video madness here. I'm going to take about 10 minutes to maybe go to get as much done of this as I can to talk about at least the first four problems. I'm going to limit this video to 10 minutes, talk about all of these proofs and the first few problems on 3-4 worksheet number 1. In the first few problems, it asks you what is true given altitudes, medians, bisect, and midpoint. So the first one says that BE is a median. So, BE is an altitude. Okay, so what that means is two things, really. It means that BE is perpendicular to AC, and angle BEC is congruent to angle BEA. So angle BEA and angle BEC are congruent right angles. So it means two things. You can have either one, but knowing either one's a good idea. AG is a median is the next problem. And that means that BG and CG are congruent. So BG, you know what? I'm going to save that one for this one, I think. I'm going to say that G is the midpoint, okay? Because G is the midpoint of BC is this problem, but AG is a median, means that G is midpoint of BC. So medians create midpoints. Medians create two congruent segments. So I think you can kind of jump ahead to this one and say G is the midpoint of BC, which is because AG is a median. So G is the midpoint of BC. You can say now that BG is congruent to CG. So really, I think that you can say BG is congruent to CG if AG is a median. So you have to make that connection. All right, the next problem says that DC bisects angle ACB. So here's DC, and angle ACB is this one right here. So that means that this angle and this angle are congruent. So angle BCD is congruent to angle ACD. That's what's true given that DC bisects that angle. All right, and angle ACB is this one. The next problem asks you to identify AD as a median, altitude, or neither, or both. Okay? So in the first problem, AD is a median because the two congruent segments are formed. In the next problem, AD is an altitude because of the congruent right angles. This one's a little tricky, but there's invisible lines here, but AD is an altitude here. And there's another congruent right angle here if you were to extend this side. But it's pretty easy to see that AD is an altitude. The last one, it's both. Because AD goes from the vertex and bisects the opposite side from these two tick marks and forms a right angle. Congruent right angles. Perpendicularly congruent right angles. So, all right, moving on then. We have some algebra. And in this problem, the algebra is x plus 40 is an expression for this segment, 2x plus 30 is an expression for this segment, and 5x minus 6 is an expression for this segment. So we have to substitute these into it. So ST is x plus 40, so that's this segment here. So I'll just write x plus 40 right next to it. SW is 2x plus 30, so I'm going to write it 2x plus 30 here. And WV is 5x minus 6, so I'm going to write 5x minus 6 right here. Now we need to find the length of SW, the length of WV, and the length of ST. And this fact that TW is a median is going to give us this expression equal to this expression. That's the equation from the facts. So we get the equation from the facts. So 2x plus 30 equals 5x minus 6. And if we solve this, we got to subtract the 5x, and we get negative 3x, and we subtract the 30, and we get equals negative 36, so x equals 12. Now, substitute it back in. Here, here, and here. And we get the length. So 2 times 12 is 24, plus 30 is 54. And this is 54 because the two segments are congruent. And then 12 plus 40 is 52. So there you have it. All right, moving on then to number 4, which is the first proof. We have an altitude. So we have to do a 2-column proof here. And when we set this up, we have statements on the left and reasons on the right. We have angle C is congruent to angle E. And that's given. And we can write that in there. Now, the next thing says that FD is an altitude. What that's going to do is give us 2 congruent right angles, right here and right here. Because altitudes create congruent right angles. It's a fact. So we'll write that in there. Number 1, FD, or number 2, FD is an altitude. And that's given. And number 3, angle CDF congruent to angle EDF. Now, because altitudes, we said altitudes already, make 2 congruent right angles. All right, so if you didn't see it already, I'm gonna move on a little bit to talk about the last proof, but this triangle and this triangle are going to be congruent. Now finish off this proof because there is the answer key on the Schoology page, and you can see we have the reflexive side, angle, angle, side, angle, angle, and then the side that's not between the two angles, and then CPCTC, which we've practiced already, but we're using this idea of altitudes, okay? Now the last 2 proofs are a little tricky, But you can see that we have two triangles in problem number 5. Okay? But in problem number 5, we're going to use CP/CTC for these two. And then we use addition to get AC congruent to BD. It's because we're adding this segment here to these two congruent segments. So problem number 5, you got to lay it out, all right, and read the answers there and see if you can get it, but it's a little tricky. But it is addition down here. See the addition property? All right, so one more step after CP/CTC. All right, the last problem here is a circle. And anytime you have this circle, you're going to use this all radii congruent. All right, we can see an OE and OC here. OE and OC. And then we have the reflexive side. Can you see the reflexive side there? And then we have to prove two angles are congruent, angle COD, right, which is this angle right there, and angle DOE, which is this angle right there. But before we do it, we have to get the triangles congruent. And you can see the two triangles. Okay? And then the two angles are by CP/CTC. All right. Well, good luck. It's a lot of work, I know, but it is honors geometry. You're expected to work at it, think about it, sit down and talk about it in your mind. Or with somebody else, that's okay too. Peace out.